All right, folks, thanks for coming to our panel today. We're here today to talk about big data, but in a kind of a different framework from what we've been hearing. This grew out of a discussion I had about 2 months ago about how to talk to CFOs about HPC, and I thought, let's expand this to big data. And I was really disappointed. I invited a person from this room to come and talk on this panel, and he said, you know what? I don't know anything about big data. These are not the droids you're looking for. And I'm like, I was really disappointed because everyone knows about big data. I go, well, what if we do this? So let's go to my title here. Talking to CFOs about HPC and big data, what if we just took that big out of there? Now, I'll bet you just about everyone in this room could get up on this panel and do a credible job talking about HPC and data. And so what we're going to do is I want to introduce my panelists. First, we have John C. Morris from Pfizer, George Ball from Raytheon, Henry Tufo from University of Colorado at Boulder, and Dr. Flavio Nussler from LexisNexis. Now, these guys are all experts in their particular field, but we're going to do a little role playing. And I'm going to be the CFO, at least in the beginning. And I read a book about big data, and I'm supposed to give a keynote about it. And here's the book, and I really recommend this, by the way, and I'm going to pass this around in a second. If you want to ever spend $15 and get a really good idea about what's happening in big data, this is the book. It just came out a couple weeks ago. This was an advanced copy I got as a reviewer. And but anyway, I'm a CFO. I read this book, and I'm ready to talk. But I brought in my heavy hitters here to straighten me out and make sure that I don't make a fool of myself, because I dress a little eccentrically, and I want people to take me seriously, right? So I should introduce myself as well. I'm Rich Brueckner. I have a publication called Inside Big Data, but most of you know me from Inside HPC, which is where I started my career way back in the 80s at Cray. So let me put the book around here. Just pass this around. Little sales pitch. I get commission on that from Amazon, by the way. So.
Is it available for Kindle?
Yeah.
First thing as a CFO is that you don't believe anybody with the title of a book like that. You know that your entire life will change because of big data.
Yeah, because it's how big data is going to change our lives, right? And so, as a CFO, I'm really dubious about this, but there were some good points in there. So let's go back to the beginning here. Because when I'm talking, I'm the guy now. When I'm talking about, I just want to know about data. I'm already investing a lot in data, and you guys have kind of hinted at me you want to do this big data thing, and I'm telling you right now, I don't have any money, right? I'm already spending a lot on that. So let's go to the next point. When I'm talking about big data, really what I mean is all data. This is analyzing all the data that we have, whether or not it was ever meant to be looked at a second time, or even related. So things like logs in computers, and Twitter streams, and our simulation analytics, all the data. So that's what I think big data means, is N equals all. And I got that from the book, by the way. So we're going to start right here. So first question, can you help me understand big data better than what I just described? Go ahead, John.
I can do my best. So I actually did a little looking up at my company about what actually.
Pull that right.
Can you hear me now?
Yeah.
So in preparation for this conversation, I did some quick reconnaissance in Pfizer, and Pfizer is a large pharmaceutical company, for those that don't know, about what actually Pfizer had for kind of storage assets, and particularly data assets in their kind of repositories. Pfizer has about 7 petabytes of data, both in structured, unstructured format, in kind of their storage systems throughout its company. They also have a large amount of what I call dark data that nobody knows about from a corporate perspective, but exists kind of in the labs or in kind of non-traditional systems that are supported by IT and stuff like that. So if I had to give the CIO some information, is Pfizer invests about $6 billion a year in R&D. And the expectation to shareholders, and more importantly to patients, is that we use that investment to make medicines that improve the quality of life, extend life, and whatnot. it's very important that that data that we're generating is actually used productively and effectively in the right time period to help make those decisions to put products through the development aspect of it. Because we're aware of, you hear about how long it takes. It's about 10 years and $1 billion for a pharmaceutical or a biotech company to identify a compound and then eventually develop it through clinical and then manufacturing through the FDA. And so it's very important that we use the information that we have and the HPC resources and algorithms, the model systems, to get access to that data and make decisions in real time. And sometimes decisions are to stop. Sometimes decisions are don't go down that path anymore. It's going to end up being a failure. So using HPC, using the data that you have, can actually have a benefit to moving the needle, to having bad compounds fail earlier, accelerating other compounds, or reallocating the critical assets and the capital that you have into what compounds you want to move further or slow down.
So this is money well spent to make sure that the money we've already spent, sounds like, is put to the best possible use.
Absolutely, because we can spend a lot of money on generating data.
Yeah.
So what's missing from big data is big analytics. You actually have to take it and do something with it and make a decision with it that, again, pushes a product to a go or no-go decision. And I think big analytics and HPC can help enable that in the right hands.
Terrific. Okay. Well, George, let's go to you, because you're part of our Raytheon group here, working with aerospace and all kinds of technologies. Can you help me understand big data from your perspective?
Well, one of the things that we see in our industry is the fact that we're having to accelerate our product development life cycles considerably. Our main customer obviously is DoD, and what they would like is an order of magnitude reduction in end-to-end life cycle development, from the concept to delivering the thing, going from, say, 20 years to 2 years. And this implies that we're going to have to research what the new product is going to look like, and we're going to have to do it much faster and hone in on what would be the best solution. And quite frankly, the way that we do things now, if we wanted to look at 5 variations on a product, that would mean putting 5 teams on it. And that would be really expensive. That's a lot of expensive manpower. Whereas if we use HPC approach and the analyzing of the data, and big data or whatever is, data's data. From our standpoint, if we can use HPC and simulation and run the analysis against the variations, the trade-offs and stuff like that, using HPC resources, that is much more cost effective, it's much faster, and the offset in terms of what we would pay for the HPC equipment, stuff like that, is considerably less than what I'm going to do if I'm going to put 5 engineering teams of 100 people each onto these things to design a new product. And if I've got 100 projects, I don't have that much resources in manpower. So my only choice then is to go to HPC and big data analysis in order to solve that kind of a problem.
So to meet our goals, you see this as the best path to get there for the least amount of money versus all these 5 teams?
When you look at the other aspect and the reason why big data becomes important, especially in this type of manufacturing, is that the ideal thing would be to eliminate bending metal. If we have to bend metal, it's a really expensive proposition. And so the more we can avoid that, the better off we are. So from a CFO standpoint, what you need to look at is, do we want to invest our dollars in the HPC equipment and do a better job of analyzing our data, or do we want to take the same approach we're doing and we get up to a certain point and we say, oh yeah, this looks pretty good, let's build a prototype, find out where we made a mistake, go back to the drawing board. We can't afford to do that. You can never shorten development life cycle sufficiently if you're simply going to follow the same process you're doing now.
Okay, thank you. So, Henry Tufo, I remember seeing a talk by you a couple of years ago about, I think you had a world record for deploying a data center in a university from start to finish of under a year, from concept to a working machine like installed. I mean, you're a bit of a risk taker, I think. So from your standpoint,
I thought it was just fool.
well, you got it done. So, what is big data to you?
Well, I mean, I really wouldn't focus on the big data piece. I think you had absolutely right in terms of focusing on data itself, and it's part really of the life cycle of HPC, and it's a critical component to it. Oh, sorry.
Pull 'em up.
It's really a critical component to it. So I really focus on the data piece, and I would lead the CFO from the HPC investments that you've already made into the data investments that are now required to bring out the value in that investment in HPC. And since you're talking to the CFO, you want two things. You want to keep it simple. Right, you want to keep it as simple as possible, and the way to his heart is through his wallet. So you want to provide a detailed cost-benefit analysis of here's an upper bound on what the costs are going to be to enhance our infrastructure to provide those capabilities. And here are the bottom line improvements that you're going to see. We're going to be able to play in these markets. We're going to enhance these revenue streams. And so I think you need to provide that to the CFO in a very clear fashion. And as I said, I really would not, the big data I find is very confusing. I mean, data and HPC, computers operate on data. I mean, that is their sole function. And, the question is we've made huge investments in sort of HPC computational plants over the years at a variety of locations. And we've talked a lot about balance in building those systems. What we haven't talked about is sort of balance in the rest of the cyber infrastructure with storage services, with networking, quality of service. And I think that's the discussion that I'd have with the CFO.
Okay. So Flavio, you're kind of my resident expert. I mean, this is your day job, right? Big data. What is it?
This is what we do. Back in maybe 12, 14 years ago, in LexisNexis, we had some data problems. We were collecting and aggregating data. This is personal data and data about motor vehicles and assets and professional licenses and criminal records and all sorts of stuff. And we were trying to do some data analysis on in this vast pool of data to provide some data analytics services. And we were using the traditional technologies that everyone knew about at that time. This is back in the late 90s. But of course, the problems we were trying to solve with those technologies didn't work. It was all of this was based on storing your data in a traditional SAN backend storage in a corner of your data center, and then moving the data all the way up to the database system that we will try to then return all the data back to you so that you can apply your analytics and then store it back all the way into the SAN. This didn't work. So we took the lessons learned that we had about some of the things that are done in the HPC world back in the day. HPC has now quite a few years of history. So we decided to apply a divide and conquer algorithm similar to what we do with HPC for numerical analysis. So essentially we built these clusters of commodity computers with local storage, so we didn't need to move the data back all the way from the corner of the data center. Now it would reside where we can apply the algorithms. And we called it HPCC. We wasn't very creative, by the way, the name. But we built a number of algorithms on data that we couldn't imagine before. One of the neat algorithms, for example, it starts with a massive data set of people in the US, and it builds a network, a social network of relationships, relatives and associates. And this is not based on birth records, because you can't get that data. It is based on different dimensions, like, for example, the cohabitation or the co-ownership of assets, essentially running a massive clustering algorithm across the, whatever it is, 200 billion data points to build this social network, which couldn't be done before. So I would tell the CFO, you know what, without big data and without this technology, you wouldn't have business. Right now, we are making billions of dollars in data services just because we can process big data the way we do.
Okay, so you made a difference there. I want to come back around here because I'm starting to get interested. And I didn't hear the word ROI. Like our friend Josh from the Zip Wheel told us, it's really about risk and opportunity costs. So based on that, John, help me define a data analysis strategy. I mean, do I really need to look at everything to do this right?
No. Well, the interesting thing, at least in the kind of pharmaceutical spaces, different data has different value. And so you can't have a one hat fits all approach or one model for that, because depending on where you're at in the product development life cycle, where you're at from kind of a regulatory aspect of it, the data has various degrees of importance, criticality, specificity, as well as domain expertise that needs to be applied to it. So a kilobyte here versus a kilobyte there are significantly different, and so you need to apply the appropriate analytical methods downstream. A lot of those are domain experts, scientists, biologists, neuroscientists, as well as the algorithms that go along with those particular technical ecosystems that go along with that data. Eventually, when you go into the clinical space, you've got regulatory, you've got compliance, you've got access controls and stuff. So there's not one shop fits all, but what you need to do is apply kind of a workflow at least around that particular space that's appropriate to that data set. The key is you need to do something with it and then move on. What happens, and I forget to present, I think it was Jeff, they had that one-way sign. Yeah. It gets read, doesn't get, I mean, it gets written, doesn't get read. That probably happens more than it should. I mean, fundamentally, if you're creating data or internalizing data within a pharmaceutical company, you should be doing something with it, making a decision, and then moving on. You may go back to it, and you should go back to it, but you should be actually making a decision at that point in time, and that's not always happening just because of the nature of research. I need to get my job done, need to do some experiment, need to fill out my journal and stuff. So a better defined process needs to exist behind each one of those acquisition points so that you can then say yes or no. Some type of decision is being made and then fed into downstream processes.
Okay, thank you. All right, so George, at Raytheon, can you help me define a strategy? I mean, do I have silos, or do I need to look at everything, or what do you think?
Well, I don't think Raytheon is unusual in the fact that we do have silos, and it's more a factor of culture. You tend to have the silos around the various engineering disciplines. So you have mechanical engineers, electrical, and stuff like that, which is not unusual. Where I think that we're heading in our industry is to break down those silos through the use of HPC and large-scale data analysis. Primarily, what we want to be able to do, and what would be the most beneficial thing, is to be able to analyze across the engineering domains simultaneously. And that is going to mean that we're going to have to take a different view of how we actually design products and stuff. Right now, just as an example, and this is true of a lot of industries, not only where I work at missile systems, but you can look at the automotive industry and a lot of other industries. You're going to build a complex product, and what you do is start off right away and decompose it into pieces. And the problem that we have is that what happens is that you actually start looking at those components as if they were standalone. And then when you try to put them back together again, you find out, okay, that doesn't work. And realistically, what you have done is taken a complex system, arbitrarily decomposed it, and assumed that if you put it back together, you get the same thing back. And that's just not true. And so in engineering disciplines, what we need to do is find a way to actually look across the domains, looking at the product you're building as a whole and how all the components are working in that space there, not as if they were isolated. The only way we can do that is through essentially HPC and big data analysis type functions.
Sure. Okay, Henry. So help me in terms of CFO can understand. How do I come up with a data analysis strategy?
So, I mean, at the university, this was a complicated discussion to have with the CFO. The basic idea that I try to encourage them to look at the problem from the computational side, right? To start with what they knew how to do, and to build off of the workflows and the analyses that are going on, a base strategy that leveraged all of what the individual silos were doing. Almost every lab or institute on campus had back-end storage, analytics capabilities, archival storage. And so the idea was basically to go ahead and provide a centralized, computational plant in some sense, and to build a research network that allow you to leverage all of the previous investments that have been made. Once you have the data on how people are using that, you can come up with a strategy to actually build out your cyber infrastructure depending upon what people are actually doing with it. Things change over time. The ways of doing business changes, the culture changes, as the technology changes, as the products they're trying to build or the research questions they're trying to answer change. And again, the basic strategy I suggested was to build a historical record, provide some base services on the storage and networking side. Once you have that, you can come up with a plan that encompasses more and more of the services that are required by the university.
Terrific. So Flavio, I've looked at some case studies of LexisNexis on this HPCC product, right? And it kind of spanned all kinds of industries. It's almost like HPC itself. So is there a common data analysis strategy there, or does it vary by problem set?
There is. Well, you need to have a common methodology in general for this type of there are, I would say, two different areas that you focus when you are doing this big data analytics. There is one which is the exploratory data analysis, and you do this when you are trying to find value for the data you have, or you are trying to identify other data elements or insights that can come from a certain data set, even standalone or integrating it with some other previous historical data that you had. On the other side, you need to be able to make these things become standard. And when it comes to that point, making them standard and reliable processes, you need to have proper data governance in place, and that is quite common across all these products. But before, I think something that they said is very important, is the fact that many of these things require this transdisciplinary type of approach. I tend to say that what a data scientist and a unicorn have in common, that nobody has ever seen one. Well, I think the North Korea people saw some unicorns, but that's a different thing. This is true. The type of skill sets that you're expecting a person to have as a data scientist, this person that knows about data and has a mathematical background and have some computer science background so that can do some programming and at the same time knows about the business problem, it's almost mythical. So you need to have people from different disciplines come together and do this type of analytics. If you're trying to do this in silos, it just doesn't work.
Well, that's helpful. So it sounds almost like anthropology, studying the whole big picture. So Flavio, let's move to the next question, because I wanted to ask you about a case study, but an example where someone or a customer or associate had an aha moment and really got what the value of big data. Can you think of an example?
Yeah, I have several of those. Sometimes, the challenge is sometimes to convince people that don't understand much how this data processing works, and where some people look at the data set and just see names or strings or numbers. Others see data, see insights information behind these numbers, right? It is the difference between what you observe, these observables, and the real entities behind. There are people that can see through. And we had many of these cases where someone comes with some data set and says, hey, and this was a good one, some insurance company that had some cases of claims, isolated claims in some southern state in the United States. And they knew that there was something that wasn't quite right. These were car claims, car accidents, and yeah, they had some things in common. They tended to be not too dangerous, or there weren't casualties in any of these claims. They ended up happening in areas that were close together, but there wasn't anything pinpointing in any one of these claims to any systematic type of fraud. So they thought that it was, well, there are some claims, that's it. So they brought us the data, and they said, what do you get from this? Well, it just took to superimpose those claims to the social graph. And we ended up finding out that every one of those claims, people that were involved in them, were all connected as part of two families in this area. They were two, either it's a case of epidemic bad luck, where families end up having these cases where they end up having car accidents, or there was some fraud behind it. And as a matter of fact, they went back, did the analysis based on the data we provided there, and they found out that it was a fraud ring. And they ended up recovering some money and sending some people to jail because of that. So that is a good example. There is another one where someone was asking us, there was this need in the government, obviously, to be more efficient. And one of the areas that is always looking for more efficiency is in the area of Medicaid, Medicare. So someone brought to us the potential for analysis where they had a number of people in Medicare, Medicaid, as you would imagine, but they were not sure if every one of these people would deserve being there because of low income and lack of assets. So we did another cross-check with our database of assets, and we ended up having a number of people in the top 100 list where they owned either expensive houses or had, for example, expensive cars like Mercedes or Lexus. By the way, we don't sell Lexus cars, so we are not that Lexus. So that shows you that as soon as you start cross-referencing data sets, you can find much more than you bargained for. And what might be just trivial data that might be unconnected, as soon as you start looking for correlations on the data, it is hard sometimes we all know, to prove causality, but at least you can prove correlations. And those correlations can be a good source for insights.
Terrific. Henry, you got any examples of the aha moment for HPC or big data?
Aha moments for academics? No, those aren't publicly spoken. I mean, I'll say my own aha moment. I mean, when I started taking a look at the complete picture of what the university was doing for its investments in HPC and data, and how they had sort of partitioned out costs, once I finally had a full picture, that was an aha moment for me in terms of how the CFO had sort of layered his costs throughout the university system to basically enhance his own revenue stream at the expense of making investments in certain areas. And this was not clear until all the data was actually brought together. So we've had lots of researchers who have had experiences that have led to new insights in the various omics disciplines.
So an agenda was there, and you just had to find the pattern.
Well, I mean, the university never wants you to put all the data together. They operate on opacity, right?
Sure.
I mean, they don't want you to know all the bits and pieces. But once you start actually digging through all the system details, it's really astounding how the money flows through the system.
Great. Okay, George, any great examples you can think? What do you think?
Well, I'd have to go back to my former life which when I was a research professor at the University of Arizona, I was working on the simulation of large-scale natural process interactions, wildland fire, and stuff like that. And this was back in the mid-'90s, and we were getting access to some of the large machines at like at Urbana-Champaign and San Diego and stuff, and running fire ecology models and stuff like that. We were seeing that there were, we're beginning to understand, here's some effects and stuff like that, and these were things that we couldn't do because we didn't have the large machines before. Now we had some big machines. We're able to run much more detailed models. And one of the things that suddenly fell out of it was that no matter how good we made the fire model, no matter how accurate we tried to do it, there was always a missing piece, and we couldn't figure it out right away. And then finally it became obvious that the limiting factor that we had was wind, and we could not generate at that time. I was started working with NCAR, but the wind profiler models weren't any better than we could only get maybe a kilometer resolution, even at the best models that we had at the time. And that wasn't good enough, because when you're looking at fire as it moves through the landscape, it's the near-Earth wind shears and stuff like that actually drive it. And then we made the next leap, which was, and there was actually data that we could never get our hands on, but you move from the small fires to the large fires, and all of a sudden the fire takes on its own life, creates its own weather, and now we can no longer model. So those were big data insights that we got because we were able to actually use HPC resources to analyze the problem sufficiently to understand how things were actually functioning.
Great. John?
Sure. So I have a work-related story, then I have a personal one. So hopefully it'll fit both those categories. So historically, large pharmaceutical companies have compound libraries of physical reagents or small molecules that they have. They probably have intellectual property rights on them. They'll literally have millions of these. But you actually will not want to run experiments on millions of these. It's very expensive, very time-consuming. So what you'll do is you'll do simulations. You'll do modeling of these in silico. The problem is these are also very expensive from a computational aspect of it. So what scientists traditionally do is they'll use a less stringent first pass to give you kind of a rough order reduction of data, and then they would do a subsequent more stringent follow-up analysis on that subset of data to get you a finalist. And that worked out well because at the time, either computation or data sets were the limiting factor in that. But as the kind of, you could scale out with either cloud services or more capabilities and computationally, some scientists went back and said, well, let's reevaluate that model right now. Let's apply the more stringent condition now that we've got more computational and storage capacity initially. Let's see if we have any of those hits that we already have IP that's already sitting in one of our freezers. Can we then do the analysis on that it may have failed initially on the less stringent one? We actually found a number of compounds that we already had in the freezer that actually looked like it had efficacy in the screening and could therefore then be tested in the laboratory space. So it was eye-opening in the fact that the new capability of larger compute, larger data allowed you to interrogate your already existing inventory in ways that you couldn't in the past. So it was a eureka moment in that fact that something you already had could be used, hopefully productively, as a compound going forward. And then going back to the CSO, normally what usually works is telling them a good, compelling story. They hate virtualization and talk about VMware and stuff like that. And so one story that I had with my son, because he always asked me, what do I do? And how do you explain to an 8-year-old that you in the HPC space and stuff like that? So we're actually at a grocery store, and I said, imagine if this entire store was filled with red jelly beans. You literally, floor to ceiling, wall to wall, red jelly beans. And it was your job to find the one orange one that was in that building. I said, it'd probably take you a long time. I said, the solution is you probably have like 1 million little kids going to the pile at once and stuff. So He got that, and that's kind of the story you got to tell your CFO, CSO, or CIO. You got to put it into something they can relate to. Probably not the jelly bean one, but he got it. He got the light bulb saying, "Oh, okay, you've distributed the problem, you've broken down into components, and everyone's got their own little algorithm." So that kind of worked for him, and stories like that I think will work as you talk to the CXOs.
Yeah. Well, thank you. Okay, so I'm going to just offer this up to anybody on the panel. I'd like to hear about a strategy that doesn't work, right? Something maybe you did or a colleague did, and they fell flat on their face, just so we have a point of reference of what not to do. Anyone? Was it talk of technology? What? Go ahead, Flavio. What do you think?
I have one on the privacy side, and what you shouldn't do is you shouldn't think that by anonymizing the data or tokenizing the data, you are ensuring that the data cannot be de-anonymized later on. And there are a few of those cases, some less fortunate than others. There is the case of the hospital in Massachusetts back in the early 2000s, whose patient data was de-anonymized. We have the Netflix case. I don't know if you know about this one. That one is a lot less impacting negatively, where Netflix had they decided to run a contest to get researchers involved in doing a better job at recommendation systems. So Netflix decided to release a bunch of their logs about customers requesting movies, but they carefully anonymized the data. They replaced every name of each customer by a number to ensure that nobody else could de-anonymize that data. Well, guess what? That is not the only source of data about people viewing movies. You have IMDb, which is a public data source out there that has people commenting on movies. What if I can correlate some of these numbers in Netflix database with some of the people commenting on movies? And what if we can identify these numbers based on the comments for movies at the right time, so you find correlations? Now suddenly your anonymized data is not such anonymized. Another one like that was the AOL case. This was about 4 or 5 years ago, where AOL released a number of web browsing habits, anonymized as well, to get a researcher interested in massive log analytics. This is, probably 2009 or so. Well, guess what? A few researchers armed with enough external data sources managed to de-anonymize many of these people. And they de-anonymized them so well that they, for example, I know this was kind of in the news. So they even found out about this little lady somewhere, I think in Arizona, with every one of her searches in her browsing, including and the news went to interview this lady and ask her why she searched for whatever medicine for her dog and something for her granddaughter. So these are some of the things that you need to be very careful when you are doing analysis on big data, particularly if that data can have an impact on lives of people. Anonymizing data in a way that it cannot be de-anonymized is an NP hard problem. So it can't be done by computers today. Armed with enough additional data sources, your anonymizing schema may fail.
Wow. Anyone else have a
I think
swing and a miss?
one of the things that Fabio mentioned, and is actually in that book that you are, getting royalties from Amazon. The authors in that book mentioned the fact that with big data, what you're actually looking at are correlations, not causation. And it's an important factor, especially when you're looking at social network analysis and stuff like that, yes, there may be correlations. One of the things, my background is actually ecology and evolutionary biology, and the aspect of looking at data in this way is that generally what we would do from a scientific standpoint is analyze it, see that we see some correlations and stuff, and then we're going to go back and we're going to look at some hypotheses and do some some actual field data and stuff like that to see if we can actually understand what the real factors are that are causing what we're seeing. And this is, I think, one of the issues that we have to be very careful of as and the ability to analyze data becomes easy for the public to do, because there are any number of cases where the public has misused things that they have suddenly had access to this person is a communist or whatever it is, and suddenly you've got a problem on your hands.
Yeah. So that is one of the premises of the book, is that sometimes just finding the correlations, letting the data speak is enough. The minute you start to figure out, well, what caused that, and do hypotheses, you're actually going astray. So it's kind of a different way of science, right? In fact, I think Flavio was telling me you really need to, instead of coming up with one hypothesis, maybe hemlines go up when Republicans get elected. Has nothing to do with anything that we can figure out. But what's important is that if we had a set of hypotheses, maybe there's something else related that ties those two together. That's good enough, is knowing what, not why.
Well, you can prove correlation, but it is very hard to prove causality.
Yeah. So I'd like to open it up to the audience here. We've got a great panel, and any strategies or things you'd like to... CFOs? No? Oh, I see Josh is smiling back there. Come on, man. You got a question? No?
I don't know.
Yeah.
Mention that similar to the point made earlier, that's how they got, most people don't know, but all the Lance Armstrong stuff on testing positive was figured out through the de-anonymization of all the blood testing done. Because if you win a race, you get tested. If you have a yellow jersey at the tour, you get tested. There's these factors. And so somebody put all of that in with the blood database, and you churn on it long enough, you find out who everybody is.
So let me repeat that. The Lance Armstrong case, apparently he was implicated by de-anonymization of blood tests and things, and he couldn't get away from the evidence that way. So he's Flavio's smiling.
I guess in that case the de-anonymization was a good thing. But
I got a hand up, Addison.
The challenge, of course, is how do you provide all of the data in aggregate without providing any of the data in specific? And this comes up with regards to regulation, in particular in certain areas like, say, financial analysis with risk management and oversight by the SEC in this country or similar, the European Commission or elsewhere, or medical data and HIPAA requirements. How do you see regulation affecting big data analysis?
There's an aspect of what you're talking about, which is the fact that when you aggregate data and you do it to a reasonable level, so you remove enough of the specificity, you actually have changed the problem space. And so the questions you can now ask are decidedly different than the ones that you had if you had the more specific information. And that becomes problematic because now if you're making an assumption based on the aggregate that you're actually understanding what the underlying problems again you get back to the same issue. And you have to really understand, again, to what Flavio was saying in terms of data scientists. You need a number of people who are going to help you understand that. I mean, my own experience has always been that, when I need to run a statistical analysis, I go find a statistician because which model am I going to use to run this data and actually understand what I've got? So,
yeah. On the regulatory side, as you can imagine, our business here in the U.S. is heavily regulated, and we are subject to almost every regulation that you can imagine, including Sarbanes-Oxley, but also HIPAA and PCI and GLBA and DPPA, and I can continue, FCRA. But fortunately, all these regulations are around data protection, but they don't get in the way of getting information from the data. Of course, they try to protect so the information doesn't get vulnerable, and if it gets vulnerable, the exposure is limited. Unfortunately, in some other countries, and you mentioned the EU, where there is a specific regulation, or there are specific regulations around a consent provided for particular uses of that data. The data science business is a lot harder, or sometimes impossible. The beauty about big data analysis is that you collected your data, you can go back and do perhaps more sophisticated analytics, or you can think of a different way of looking at the data, and you can get other information that you didn't see before. Now, imagine if every one of the data elements that you had in that big data was to be used only for a particular type of analysis and nothing else, because that was what the person consented on that data being used for. Now, suddenly, you can't do almost anything after the fact. You need to think of what you want to get from that data even before you collected it, which kind of kills all the innovation, all the creativity that you can have with that data.
Answer your question, Addison? Yeah, he's good?
Quick comment on that.
Yeah, quick.
So obviously being in the pharmaceutical space, it's a heavily regulated, as it should be, environment. There are very strict firewalls around, especially the clinical data and whatnot. One of the things that struck me is obviously, while you can possibly do it, if you de-anonymize the data, or if you anonymize the data, sorry. Some of the ethical questions started coming up, because you think about recently in the news we had, I believe CVS was trying to ask their employees, depending on their weight, to potentially be more or less from healthcare perspective. Now, I guarantee that if you have a big enough data set with all the samples behind it, you can start doing some modeling and look at biomarker predictions of individuals who may be more or less susceptible to different types of conditions. We're not that far away from being able to do that. And then what is the consequence of being able to predict future health issues? Now, it's a prediction. It's not an actuality. But there's a strong statistical correlation with it that's going to be behind it that will maybe start influencing policies and regulations going forward and stuff. So just because you can, should you, and there's a lot of gray areas around the ethics of this that I think are going to start coming up as you have the ability to analyze larger data sets, especially around individual and health issues.
Very good. Anyone else? All right, panelists, any closing thoughts? Flavio's reaching for the mic. There he is.
Well, I think this one is a very important one. There is a gray area that separates the usefulness of big data analytics and being creepy. Right, we need to try to avoid crossing that line, right? And whatever you do with the data needs to be for good use and not to harass or stalk someone.
Minority Report, right? Yeah. Anybody else? All right. Well, hey, folks, let's give our panelists a great hand. They did a great job.